Hi, can I jump in? I'm sorry to interrupt. I had a quick question, I believe for Thomas. This is Adrian, but you mentioned the a motorized focus for the dish,
Yes.
and I'm just curious. Does that adjust basically sort of an in and out dimensional change for the focus, or can you also have like lateral adjustments
No, this
for
is
the
indeed this is indeed just forward and backward basically. So not
okay.
not not lateral, but over quite some distance. And I have a few graphs that show this, even for X-band, and it's really interesting to see how insensitive it basically is for that. And we also do have a very complex pointing model of the telescope, which also allows you to have feeds that are not in the center. So basically that they have a lateral movement. But that's a different topic.
Would that be like offset feeds for dishes or?
No, it's not really an offset feed. It's more simply because you cannot have everything in focus if you have multiple feeds.
Right.
But then you need to change the pointing. So you will have some loss that's unavoidable, but you will change the pointing. And the pointing model also contains some of the parameters that you mentioned earlier, like deformation because of the elevation and things like that, or even if the telescope is not completely leveled and things like that.
Wow. All sorts of details.
And
There's
I'm
always
sorry,
more detail.
what radio telescope are you involved with, sir?
Oh, this is the Dwingelo telescope in
Oh,
the
the Twiggle.
Netherlands.
Oh,
Yeah.
okay, yeah, okay. I'm familiar with. Well, offhand with the with the Dwingelo telescope. Yeah, because I mean, in the discussion about the potential, gosh, I mean, I agree. I can't believe something like a 20 dB loss. That's just from the predicted or theoretical just seems completely unbelievable. That's the first thing that came to mind. Maybe not necessarily dish deformation, but just whether they were perhaps maybe laterally out of the focal point, and so
Right.
maybe
Yeah,
the
pointing,
pointing.
no, yeah, like pointing error is one,
Yeah,
and just and that's not the only error. There's tons of different things that can happen. And yeah, I mean, the Alex and the folks at DSES are knocking them down, and there's some. I think that the big benefit of the Earth Venus Earth event back in March, there's been a galvanization, like a realization of like, oh shoot, like now we know um what to look like. We need to go through and look at everything, and there's a good amount of energy and motivation to dig in and figure it out and to correct the issues. And there's a increase in the quality of the conversation and the amount of energy being put into it. Of course, this is all duh. Of course, this is what should happen when you have a big event and you get some results. So the good news is that the stuff's getting looked at and quantified and discussed, and there's going to be basically a top down look at everything. So by the time we come around to the next inferior conjunction and they really, really, really want to try again, then the results will be much better. So that's the good news. Yeah, but the deficit for the results is a lot. I think Alex said 12 to 20 dB, with some of that being explained by things like the feed lines needed to be replaced. There's lots and lots of stuff in the way. The order that you put things in matters. So things are moving in the right direction, and I think we'll get better results next time around. And the same sort of process is going on at all of the other sites involved. Absolutely sure that it's very clear that Dwingelo's taking these results and running with them. There's an awful lot of effort being put into designing communications protocols that take full advantage of the link, understanding delay Doppler stuff, and the channel. Um, and making sure that equipment's tested in advance, things like that. This is happening at Dwingelo and Stockert, and we're really hoping to expand the number of sites, amateur sites that are involved. So, all good news. DSES may have to make up for a little bit more than some of the other sites. But I think we're all on the right track, and we're committed to helping them figure it out, um, and giving advice, practical solutions for defining, like, the dish surface, figuring it out in a way that isn't super expensive or complicated. And yeah, the photography method it works, as long as you have enough photos and the right software. There's at least 3 or 4 different ways to do this. At least one proprietary commercial way and a couple of open source mesh models. And it'll result in some knowledge and put it forward. I'm gonna bet that the surface of the dish is worse than they think, but not it will not explain all of the loss. That there's something else going on there. There's something else that's happening. Um, and I'm very confident that we'll figure it out.
Yeah, well, if my understanding is correct, the attempt for the next conjunction, they were planning on moving from the 1200 uh, megahertz region up to the next band up at what is it, 23 or 2400. And if
Yes,
that's the case, then this is going to become an even more critical problem,
right.
uh, jumping up to almost twice the frequency. If they have that kind of discontinuity in the parabolic shape of the dish, and the surface RMS is that off, then it's just going to really be an increasingly worse problem
Yeah,
going to
that's
that.
true. You're right. There's certain things that when you go up in frequency, they start to matter more. And it's true. It'll make more of a difference. So knowing that will only help. The good news about 2.3, 2.4 gigahertz is that that's really what you want to use for Venus. It really does give you advantages in terms of albedo, the radar reflection from Venus, and it's a better frequency to use. So there's benefits right off the bat. And if we can then mitigate the disadvantages to moving up in frequency, requiring you to have a tighter ship, for instance, um, that then it's all good. We're all moving in the right direction.
And also the equipment required for that band, and the power that they're planning on
Hmm.
trying to use.
Yeah.
And I sort of sat in on maybe some of that discussion, listening in, and they were planning on using some outrageous number of parallel transmitters to try to
Yeah.
achieve
Yeah.
that kind of power output. And that to me just seems like a huge complexity of attempting to do that with just a solid state type systems, and and trying to and also, gosh, the problems they had even with just a couple of the transmitters they had at 1200 with the
Yeah, there were
power and
two.
so forth.
Yeah, it was
Yes,
like a dual transmitter thing.
right.
Yeah, I
I
think
think so. Yeah.
the lesson has been learned that you really need to test it a lot. Like, test it, make it really simple, test again, characterize it. You're I think that, yeah, the lesson has been absorbed. And there's active discussions on how to create enough power at 2 point whatever, 2304 megahertz. And it needs to be reliable. And you really do need to test this stuff well ahead of time. And the management of the heat is a challenge. And you can see that, you know, um, multiple experiences with the, challenge with the heat produced by these transmitters is a big deal. So I think, message received, and I'm looking forward to seeing some good designs, and some, maybe more testing in advance to be more confident of the hardware, not waiting until the weekend to install it, that sort of thing. So I'm hoping that will happen, and expecting that will happen for October of next year.
Yeah, and I just wonder if maybe I don't know, maybe going back to some of the equipment as the sort of the original EVE accomplishment, where it was not a solid state transmitter, but frequency locked and phase locked magnetron that was used
Right.
for
Yeah,
the
it was
output.
that was quite the that was quite the piece of kit. Um, a huge amount of power, and I
Well, I
think that
think they were.
one of the things that folks wanted to do this time around was to achieve this result without having to use that much power, which happened. The result was attained, without having to use 6,000 watts of a magnetron. True, though, that clearly worked.
I'm very sure we have the world record on the lowest power Venus
Yes,
bounce ever.
I think you
So
do.
maybe we should actually make that the target instead of creating more power.
Yeah. I mean, it is a relief valve, in one way of looking at it. Like it is a degree of freedom that you have it to go back to, well, just, defeat it with horsepower, But I think the trend pretty much is to try to do this with the minimum amount of power, which is kind of something that at least U.S. hams are used to hearing. We're used to hearing, for at least from our regulatory framework, that we're supposed to achieve the communications with the least amount of power required. That's kind of the challenge to us is to do that. So I the trend is to not have 5 or 6 thousand watts and blast Venus. So we'll see. But
Well, I'm not.
even if you have like just 1,000 watts or 600 watts or whatever watts, it needs to be reliable, needs to be tested in advance. Can't push this off into the last minute. You can't be clapping together two transmitters the that weekend and hauling them up to the dish and hoping it works. Like, crossing your fingers. Like you really do have to know what you're transmitting. That is something that I think will go better next time.
Yeah, well, I don't even know if the FCC would authorize 6 kilowatts, but certainly lower power non-solid state devices are available,
Yeah.
and they could try to. Of course, I'm not sure financially which way you're better off, either getting 6 or 7 or 8 or 9 or 10, 100 watt 2.3 gig transmitters and paralleling them together, or maybe just finding some kind of perhaps a surplus klystron or TWT or something that might be in that sort of kilowatt range that they're
Right.
planning on reaching,
Yeah.
and uh, and that would be that certainly would simplify the multiplicity of multiple transmitters that you would have to have operating just pretty much effectively to achieve the full power that they require. But just a thought. But I was just curious. I'm not very much into the parabolic sort of surface determination. So I was just kind of curious. Would these pictures all be taken from the focal point, or and you're just moving the camera throughout the surface, pointing at the surface of the antenna in order to determine the
Oh,
RMS?
no, that's a really good question. I think because when you're talking about a dish and you're talking about focal points and like what the dish looks like and determining the surface, it might seem like that you should take a bunch of photos from the focal point looking at the dish. The real power of this particular technique is that you take as many photographs of the dish from as many different angles as you possibly can, and that you're moving through space and you're getting as many different combinations of these reflective points, these defined points on the surface that you can. So, in other words, imagine if you were trying to get the surface, to determine the surface of a horse, and you speckled the horse. Like imagine it's an Appaloosa. You've speckled this horse with a whole bunch of different tags. You've spewed a whole bunch of different QR codes or whatever on it. In order to determine the shape of the horse, you have to walk around it and let your binocular vision in your head appreciate all the different surfaces of this animal. So this is the same sort of deal. You need to develop a three-dimensional model of something, so you have to move the point of which you're taking the photograph, the viewpoint of the camera. You have to move it around so that you can get as many different relative positions as you possibly can. And then you let a computer program crunch it for you, and it produces a mesh. And and that's kind of the deal. So, from a sort of a simulation point of view, yes, it seems like you should be able to take one photograph from the focal point and get the whole dish. Now, if you could do an echogram from every different point of the dish from the focal point, you would get that. So you could sit at the focal point and take a LiDAR, you know, a laser level or laser meter and get the distance to every single point on the dish. And there are very expensive services and apparatus that will let you do that. This particular method, though, anybody can do it, and they can do it with a typical like digital SLR. Even a cell phone will do it. A modern cell phone camera has enough pixels, has enough resolution to do this. So this is just a method of gathering what your binocular vision does for you when you're moving around an object and you're looking at it. This is to do in software what you're doing in your head to wander around a three-dimensional object and develop a model of it in your mind.
I see. Uh, that kind of makes sense. Yeah. So you're basically not because I was just wondering, gosh, you would think like with as you mentioned, like with a laser, the distance is the critical point that you're measuring. But I guess in this sense, it's more the angles that are uh, perspective angles that are used in the computation of the measurement. Is that
Right.
correct?
Yeah, it's all trig
Yeah,
all the
I
time
see.
in
Yeah,
these, you
that
know.
makes sense. I've had a little bit of experience. I have just a small I guess it's about a 2.4 meter TVRO dish that I put in my backyard many years ago, and during some gigantic windstorm, it sort of warped the dish to some degree. I sort of manhandled it back into sort of a semi more eyeball parabolic shape, but it did change the lateral aiming for the focal point. Of course, this is pointing just to the geostationary satellites back when there was still stuff that you could watch out of those. And so I did notice that then after the re dimensional sort of changes on the dish that yeah the previous focal point was not really the correct one
Right.
for when
Yeah.
you aim,
Right.
and it made a huge difference now by changing. And of course, I could just sort of tweak this thing up and down. I have
Bend
a
it. Yeah.
yeah, no, not bending, just the pointing. I have a horizon to horizon sort of um, uh, uh, azimuth sort of movement that I could just sort of like pulse it and then go back and forth, and it was changing the where the aiming point was previous to the wind damage, and so I was just curious if perhaps maybe their problem was just not like as I said, just there might not be necessarily at the focal point that they're
Right.
aiming through laterally. So
Right.
I kind of agree with Thomas. I've played around with the feed on it, and yeah, you can move it in and out to sort of pretty pretty dramatically, not see a big change. But boy, just the shape and the alteration in the shape of the dish made a huge difference as to the laterally as to the pointing now for
Right.
where the satellites were locked in before.
Right.
So and again, this is just a very small scale, not comparable to the SES dish,
Well,
but
no, in
it
a lot of
does.
ways, I mean, mathematically, I think, yeah, I mean, you got you it's a smaller dish, sure, but I think you're seeing the same sort of things going on. So, as
Yeah.
soon as we can get this nailed down and quantified, the better we can make the link budget and, explain the discrepancies between what's expected from a reasonable link budget and what they actually are seeing happening at their dish. And so the stuff that you're talking about applies. It's the same sort of physics. It's the same math. And Yeah, I guess I assumed that the in and out, like going in and through the focal point, would, from the in and out would make more of a difference. But in thinking about it, it really doesn't. It just really changes. Um, it changes a bit of the whether it's a little bit blurry. But at the same time, you're counteracting that with over illuminating and under illuminating your dish. So there's actually some balance there.
Right.
Up to a point. So that makes sense to me. So we'll know soon. They were enthusiastic about this. They see a path forward. It's equipment they already have. It's not hiring, some backlogged service to come in. It's they can do it. They can make a workshop out of it, and they'll get some really cool artifacts out of it, which Thomas has shared in the chat some really amazing looking uh, diagrams, especially this middle one with the black background that looks like the dish architecture itself, like the mechanics, like what the dish looks like, and the bottom one looks like a surface. I mean, these sorts
Yeah.
of things, DSS simply does not have. They do not have anything like that. They don't know what it looks like, but they're going to get a surface. And I told them, you could now show people in a slide like the actual surface of the dish. Like, wouldn't that be great? Like something like what we see in the chat here. This is completely amazing. Like, you need to know what you have.
Oh, it's critical. Yeah.
It You have to. And you know, it's I think we'll get that. We'll get there.
I sort of had a thought. It might be overly simplistic and totally impractical, but I was just wondering if there are plenty of and I'm sure that even at the frequency range that they're pretty much set up for doing like hydrogen line and so forth. The beam width of the of that of their dish is probably somewhat around 1 degree or in that range, maybe a little bit less. Um, if I'm not mistaken. But I was just curious if perhaps if they were to find a nice sort of a point source. I mean, they're for example, masers. They've actually been able to detect, as I think, masers, which would kind of look point source from the beam angle of their dish. And if they could just do like a raster scan.
Oh yeah. Yeah, that was part of our recommendation.
Okay, and then that would maybe at least give
Yeah,
an indication of the if the
right.
pointing error is what's causing the problem. They could lock in
Right.
uh, exactly where the object is in their raster scan, and then being able to determine whether
Right.
it was offset or
Yeah. Yeah.
whatnot.
No, you're totally on the right track here.
Okay,
Part of the one of the recommendations was to pick a local source or some source, some known source, and then like do a formal antenna pattern or which is essentially a raster search, and then record the power, and then show what you see, and that would reveal quite a lot. They do have at least one result along these lines, and Alex and Paul, the current president, were very enthusiastic about this. It's going to happen, and they'll get a whole lot more really good data this way. It will things are moving forward. With a I mean, the dish was well under revival by 2010 when I first joined DSES and first found out about them at Microwave Update. Um, the first wave of work, a lot of this was probably done by people like us that knew what they were after. Uh, the the bad news is that if that information or if these test results were ever written down, they were not handed off to the next generation of leaders of the dish. So there are people who insist that this is already known and it's already been accounted for, but can no one can put their hands on the results. So if it wasn't documented or if the documentation has been lost, that's essentially the same as if it has not been done. And that now it's a person problem, it's a communications problem to like, no, we need to do this again. I can totally understand why there's any resistance towards, well, why do we have to do this again? We did this once, everything was fine, or we knew the results at one point. So completely understandable. I have nothing but empathy for this, but now it's 2025, and we need these we need this information. We need to know what it looks like. We need to know what the deformation is. We need to know, where the losses are. We need to know what the antenna pattern is, those sorts of things. So it's going to get done.
Yeah,
And then
that's absolutely.
and they're like very motivated on like this needs to not just be written down. It needs to be published somewhere where people can see it. And I'm like, yes, that's exactly right. It needs to be in an open repository on your website, a couple of different places, in a way that makes it useful for anybody that wants to engage with the dish. They need to know these things and need to be explained and documented and all that. So no time like the present to 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 do it right. And yes, this stuff could have been done in the past, 15, 20 years ago, and just simply not handed off. It could be in a binder somewhere, in a three-ring binder on somebody's shelf, um, at somebody's desk or in somebody's computer. Um, but we don't have it. So the only choice is to move forward and to redo it and then to publish it, to make it public, uh, present it to the community and maintain that archive and make sure that's available to people so that they can propose, um, you know, appropriate things for the dish to do. So if we have some limitations, if it turns out to be a 11 millimeter RMS, that will limit the dish's performance. And there are things that it won't be able to do. So it's better to know and then to focus on things that it can do rather than settling for failure. So
Well,
that's kind of that's kind of the meta argument. That's kind of the sort of the leadership approach to this.
well, not only is this documentation is really important, but I think it could also be very valuable as essentially a diagnostic tool, uh, because I mean the assumption is that the dish was built to certain specifications, and maybe
Yeah.
with time it might have warped or something, but it could
Yeah.
also be an indication of perhaps structural failure. I mean,
Right.
look at the original Green Bank Observatory telescope that overnight one time just fully collapsed before they actually built the one that's there now.
Yeah. Or
And look,
Arecibo or
yeah, well, Arecibo, of course, the supporting cables for the feed were the problem there,
yeah.
but in any case, those things are hard to spot. And
Yeah.
gosh, I know, for example, the 100-meter Greenback telescope is now down for several months
Right.
due to some scheduled maintenance, and I'm sure that the SES people don't have anywhere near the resources that the National Radio Astronomy uh, federal agency has, and so they might not be capable to necessarily have the structural, uh, inspections to determine if there's some kind of a structural failure that's
Right.
ongoing that would be causing some really major distortion of the dish.
I
And
mean,
if this
we
method
might not be
works,
able to stop it but we have an immense amount of flexibility and focus here, so once if we identify a problem, an organization like DSES with this one site, we have a tremendous amount of power over fixing things. So we can actually address and fix and we could uh, decide that if there was something that was really off, rip it out and get it made and put it back in.
well,
So that's the advantage to some agility and being able to owning the site, having a foundation or a
right. Well,
organization set up just to do it. So we can address it just because of the flexibility and agility of a organization devoted to it. But without measuring it, then no one has the
and
information to make the decisions.
and of course the point is getting to it before it would become a catastrophic failure. And so
Yeah.
that's what I was trying to say, that if you were able to do this method and then do it repeatedly, like
Oh, yeah,
regularly
to monitor. You mean
every
like to
yeah,
monitor?
exactly, that's my
Yeah.
point. So every 6 months or a year or something, do the analysis, and if you begin to see now some major changes that could pinpoint perhaps the indication that you need to seriously look at maybe some kind of structural
A good point.
reason for that.
I think that's
So
a, I didn't even really
yeah.
think of that as an
Oh
ongoing,
yeah. No,
just
I think
this
because
is
that's the thing,
one,
the
like
being able
we'll
to
figure it
monitor.
out
Yeah.
and then fold it into the budget. But yeah, you're right. This is an ongoing sort of maintenance thing.
So that might be something that they might want to consider. I just kind of thought that might be a
Yeah, I'll bring it
possibility
up.
of use. Yeah.
Or the next time that you're on a meeting,
Sure.
mention it. Maybe mention it. It's good. It's
Either
always good
way,
to hear it from multiple people.
just to bring it up so they have maybe some concept,
Yeah.
as you said, maybe no one's thought of it, but I think as a monitoring
Yeah.
system it might be really valuable to
Yeah.
address any potential issues like that.
So
Anyway, I just thought I'd bring that up.
yeah, no, I mean they're now monitoring weather at the site, and other things at the site. So I mean, as more and more sensors are deployed and more data over time, time series data is collected. This is just another thing to add, put in there. It's useful.
And one other thing I thought that they might try, and this might be more difficult, but sort of as a practice exercise, if they could just actually try to, I know they can do moon bounce, and it's just like nothing, uh, nothing
Yeah, they call it boring.
yeah, I call it boring. So I thought, gosh, there's quite a bit of these near Earth asteroids
Yeah,
that
yeah.
kind of fly by, and if they could just sort of try to target some of these things and try to maybe get signals bounce off of them, that might be able to give some
Yeah,
practice
there's
being
other
able.
stuff to bounce off of other than Venus and the moon. So yeah,
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 yeah. So
might be able to get them excited about that.
I kind of mentioned it to someone to them. They said, "Wow, we never really thought of that." And so I
Okay.
thought, "Gee, that could be an exercise." I mean, these things come by fairly regularly. I know, well, JPL and well, not JPL, but NASA and even Greenback regularly, and of course, Arecibo used to do that. I saw those
Yeah.
incredible radar images of some of these near-Earth asteroids
Right, and
that would
they
come
couldn't
by.
even they can't even point. Arecibo just let stuff drift by and bounce off and report it.
Well, they had a little bit of leeway because the Arecibo was not a parabola; it was a spheroid mirror,
Right.
and so they could move that feed around and sort of
Yeah.
get a little bit of pointing, as you said, because it wasn't really a focal point. It was just kind of like looking at a really distorted sort of non-parabolic, a a critical sort of spherical shape, and so there's no defined central focal point. You can just move the feed around and get still some reflections that increase your signal, but it wasn't
Yeah.
actually straight up where the feed is at a focal point that they could move that. But no, I'm saying that the radar images that they were still able to generate is just incredible. And I think GBT is getting set up now also for installation of transmitting capability now, so they can
Oh, cool.
they actually already have done an experimental, really low power transmitter that was installed, and they were actually able to do some radar imaging of the moon. I think that's been published, and it's amazing. So the resolution that they were able to get out of that, yeah, because it's at a much higher frequency that I don't think Arecibo could do much more above 400 megahertz or something like that.
Yeah,
They're
it was limited.
Yeah, so
Got a higher there's a higher ceiling with
yeah,
the
the 100 meter can
flow
go up to,
pocket.
gosh, dozens of gigahertz at least,
Right.
and so the resolution is fine. But yeah, that would be exciting for DSES to be able to try to do something like that and maybe get a practice runs on something like this. But
Well, we'll
uh,
see what we can do to
yeah, it's
influence it and
exciting. I'm
to,
just sort of stoked on it.
yeah, I think yeah, we're all the right steps are being taken and we're giving them a lot of support and encouragement and we'll just keep at it and I think that things will go much better in next year and that there will be many benefits to this work, not just to the amateur radio side of the house, but also to the astronomy, amateur astronomy side of the house as well. Any improvements that are made will help both endeavors, both sets of projects. So it's good work and fits in with what we're supposed to be doing at ORI. So I guess yeah, no, that's good stuff, and I thank you so much for all the contributions and ideas. Um, and I think yeah, we'll be publishing a lot more about this over the next year and we'll just keep plugging away. So I'm going to turn the floor over to Paul to bring us up to date on anything that we need to know about in the lab? Anything over the next week that we might need to know about? Any resources that you need, or any particular problems that you're having in the lab work?
Okay, well, not much to report actually. Been little activity over the last week. Um, Actually, user activity has been essentially zero for a while because of other things going on. Um, my plans remain unchanged, but also unaccomplished. So work is going on theoretically.
I know we've accomplished quite a bit as of last week, but yeah, the previous week has been most people have been on travel and doing other things. Anything in particular over the next week that you'd like to get done or that folks need to know about?
There are tests I want to run, some experiments I want to do on the offline version of the computer. That won't be impacting anybody else since nobody else is using that system yet. Um, Hopefully some useful information will come out of that, and then I'll be able to transfer upgrades to the online system.
Yeah, I think that's the big project that we're engaged in. Um, in addition to trying to reach out to local universities and get more engagement with communities and academia. I know that I'll definitely be using the lab coming up here for the state machine um, that we have in an opulent voice. So I'll be relying very heavily on remote lab and all of the things that we got going on there. Um, so I'll just work around anything that needs to happen in the main lab. And I know that the experiments that you're talking about will be in the remote lab south equipment. So it should not be in conflict. So that's what I know for the next week or so.
Yeah, that's all correct. Uh, I will, yeah, shouldn't be any disruption to your work on the Remote Lab West.
And then anything that Matthew might need tried out. So that should be able to move forward, no problem.
As far as I know,
Cool. Okay. Well, we'll stick
notice
with that.
I noticed that Thomas, before he had to leave, posted a book link, which is of some interest in the chat.
Oh, what's that?
It's a book about parabolic antennas for astronomy, a whole book about them. Looks like it might be of interest if
Oh,
anybody's interested in working on big parabolic dish antennas.
okay. I'll make sure that gets into the recording so that folks can follow it. Groovy. Okay. Any other comments or questions before we close for the day?
For me.
Well, thank you to all who have joined us and who will join us in the future for all of your amazing work and your energy and attention. We'll keep moving things forward and contributing in every possible way that we can. And we'll meet again next week, and we'll pick up the discussion on Slack. If you're wanting to get involved, if you're watching this, then please visit openresearch.institute and go to the Getting Started link and reach out. And we welcome you and your projects and your energy. So thanks so much, everybody, and see you real soon.